All right, this is kind of a fun problem. It says Christy has tied a string that is 24 centimeters long into a closed loop, like the one at the right. So the key here is that this string is 24 centimeters long. She's decided to form an equilateral triangle with her string. What is the area of the triangle? So for A, if she's making an equilateral triangle with her string, we know that 24 divided by 3 is 8. So each sides of the equilateral triangle have to be 8 units. So then what is the area of the triangle? So first we know what the sides are. We know the formula is going to be A equals 1/2 base times height. So then we know this is 1/2 times the base, which is 8. But the problem is we don't know what the height is. That's this distance here, but we can find it because we know this angle here is 60. And we know if this whole length here is 8, then we know this is 4, and this length here has to be 4 root 3. So then this is times 4 root 3. And then we get 1/2 of 8 is 4. 4 times 4 is 16 root 3. And that's units. What were my units? Centimeters. So this is going to be centimeters squared. Okay, now it doesn't say anything about approximating or anything, so I'm just going to leave my answers in exact form. All right, so then she must be bored because she forms she forms a square with the same loop of string. So now if she forms a square, we know that all of these sides are equal. So now we take 24 and divide it by 4 sides, and we get 6. So then we know each of these are 6. They want to know what is the area of the square. So we know area equals s squared. So we know the side is 6. So then we know this is 36 centimeters squared. And then it says, is it more or less than the equilateral triangle she created in part A? Well, we need to compare it. I used exact answers, so I want to come back 16 times root 3. And then this is what? 27.7 centimeters. So is it bigger or smaller? Oh, it's definitely bigger. So this is bigger. Oopsie. Bigger. Okay. All right, so then having all kinds of fun here. She takes that same bit of string and she forms a regular hexagon. And then what's the area? All right, so then we find the hexagon. And we would find the angles, and hopefully everybody, we've worked with the hexagon enough to know. We can take, we know there's going to be 6 triangles times n sides equals 360. So n equals 60. So I know these angles here are going to be 60 in here. And so when I draw this straight down, I'm going to get a right triangle, right? So I'm going to get this right triangle. I know if we do half, this is going to be 30, and I know this is going to be 60 degrees. And I know that I have a 30, 60, 90 triangle. I know what those angles are. What I didn't do is I have 24, and then what do I divide it by? How many sides? 6 sides, and I get 4. So then I know each one of these has to be 4 units. So then I know this is going to be 2 units. And because it's a 30, 60, 90 triangle, I know this is going to be 2 root 3. So the area of one triangle is going to be 1/2 the base, which is 4, times the height, which is going to be 2 root 3. And then A equals 1/2 4 is 2. And then half of 4 is 2, and then times 2 root 3, that's going to be 4 root 3. And that's just one triangle, so I want the area of 6 sides, so that's going to be 6 times 4 root 3, which this is going to be 24 root 3. And it looks like we need approximate answer, so I'm going to take 24 times root 3, and I get that the area of 6 sides of a regular hexagon is 41 point, we'll say 0.6 units squared. All right. So now it says compare this area with the areas of the square and the equilateral triangle from parts A and B. Well, it looks like it's even bigger, right? It's bigger. And then what we want to do is we've got to look at D. And then it says, what shape do you think that Christie conjectures will enclose the greatest area? Well, as I look at this, I see 3 sides, 4 sides, 5 sides, and each of the sides are getting smaller, and so we've talked about infinitely small sides, which is a circle, essentially. So I'm going to conjecture that a circle will have the largest, I'm going to conjecture that a circle will have the largest area.